Hello everyone! In this video I'm going to show you the core features of our web app Argus. Argus is tailored towards rescue forces, specifically drone units, who use UAVs mostly for reconnaissance. Argus allows you to document and analyze drone flights as well as present your data in a more structured manner than simply throwing all of your images inside of a folder on your system. You can get Argus on Github and use the install script to set up the Docker container and start Argus. Once started, it can be accessed via a web browser, preferably Chrome or Chromium, by entering the corresponding IP address. That also allows you to run the Argus server either locally or on a more powerful server within your network and use it from different clients. On the start page you see your existing projects. If it is your first time running Argus, there will be no projects, but if you want to, you can load an already processed example project from a flooding in Germany in 2021 by clicking on New Report and then select Project zip file and import. We will instead now generate a new example project from a recent training with firefighters about wildfires. After entering the title and the description, we can create and open the project. Now we can either upload the images by drag and drop or use the file chooser to add them. I'll add mine, and while it is uploading, we will take a look at the settings. Since Argus was mainly developed to process mapping flights, we want to check the option Fast Mapping to create a simple orthophoto. The Fast Mapping uses our own algorithm and maps the images only based on their GPS coordinate and orientation. This may result in some visible edges between the individual images, but it is a very robust and fast technique that requires almost no overlap and is well suited for how to process data like infrared images. As you can see, we have also incorporated the popular drone software OpenDroneMaps. We can use it to process another better orthophoto after the fast mapping, but keep in mind that this will take a lot longer than the fast mapping. Once all images are uploaded to your local server, we can start processing. Currently, Argus is only tested with DJI drones like the M30T and the Mavic and Mavic Enterprise drones. Once the pre-processing is finished, you will be redirected to the created report. While the orthophotos are processed, we can already take a look around the report. We can see some basic information about the flight, the drone and the weather. Down here we can see an interactive map, where our first fast mapping has already appeared. You can use this to overlay against an online map to observe changes in your site. If we click on an image in the map, the report automatically opens it in a slideshow where we can use a magnifier or, if given, overlay and analyze IR images. Below you can see a gallery of all images structured by RGB, infrared, and, if available, also panoramic 360-degree images. Let's take a look into another report to see how panoramic images are presented. In this case, there are three 360-degree images taken during the flight. They can be opened by clicking onto the pin on the map or by selecting them in their gallery tab at the bottom. The report will show them inside a 360-degree viewer where they can get explored and opened into full screen. The fast orthophotos are already finished, but we may need to wait another 3 to 4 minutes for the WebODM maps. It seems like most of the maps are already generated. To further analyze the images, our own trained AI model can be used to find objects like fires, cars or people. Therefore, we trained this model on our own dataset, which is also available on Kaggle. You can choose to split up the images multiple times to also find smaller details by using the image detection. For this video, I've selected no splits, since we just want to see a quick overview of the functionalities. Once the detection is done, some statistics are given about how many objects were found. Keep in mind that currently objects seen in multiple images will be counted as often as they were detected. But to give a better overview, they get visualized in the map as well. The visualization is currently still in development, but as of right now, the colored dots each represent an object detection of a certain class. If it gets too cluttered, you can raise the detection threshold or deactivate a category completely. We can also see the detections per image on the map. If you click on the images icon, the report will scroll down to the slideshow and you can take a closer look on the detections. Finally, you can use WebODM to generate a 3D model from your images. Just scroll up to 3D Model WebODM and click Generate a 3D Model with WebODM. Since this video is already long enough, I will just show you the results of an older report where the model has already been processed. As you can see, Argus also allows you to open WebODM directly from the project's overview. For now, that's all I want to show you. Argus is currently developed by a small team at the Westphalian University of Applied Sciences as part of the German Rescue Robotics Research Project funded by the German Federal Ministry of Education and Research. Keep in mind that Argus is not a polished software, it is still in development. If you want to try Argus yourself, check out our GitHub repository in the link below.